Happy Friday, everybody. Now, if you remember, yesterday we were working on representing the sample space of compound events, which means compound events means two or more events, okay, that are happening. And remember, when we're representing the events, we could represent it in a tree diagram, we could represent it in a list, or we could represent it in a table. Okay. And so I showed you representing it in all of these different types of areas. And if you remember, if you remember, the product of the sample spaces of each event represents the total possible outcomes. And so that's going to help us whenever we're trying to find the probability of compound events, which means two or more events. So let's look at it down here and see what I'm talking about. So it has a blue spinner, okay? And then this is a six-sided die, which is going to have the numbers 1, 2, 3, 4, 5, and 6. And so number 9 is asking for the probability, P stands for probability, that will land on blue first and then a 2. Well, we know that this has 4 different possibilities, right? We can land on red 1, red 2. We can land on blue, or we can land on yellow. Notice that there's 2 reds here. So there are 4 different possibilities in the sample space for the event number 1. This is the first event. We're spinning the spinner. The second event is going to be rolling the die. And here we can roll a 1, a 2, 3, 4, 5, and a 6, which is 6 total possibilities. So if I were going to represent this sample space, I could make a table, which is my favorite because it proves to you how compound probability works. Let me draw my lines here. Okay. So I could roll a red 1, we'll call this red 1, and we'll call this one red 2. So I could roll a red 1 and then a 1, a red 1 and then a 2, a red 1 and then a 3, a red 1 and then a 4, a red 1 and then a 5, and then I could also roll a red 1 and then get a 6. So there's 6 possibilities right there of the compound event. Okay, or for my first event, I could roll a red 2, and then I could get a 1. I could roll a red 2 and then get a 2. I could roll a red 2 and then get a 3. I could roll the second red and then get the 4, the second red, and then get a 5, or I could roll the second red and then get a 6. And I feel like you may be seeing where I'm going with this, but let me go ahead and finish it out. But what if I don't get any red? I can also get a blue and then a 1, a blue and then a 2, a blue and then a 3, a blue and then a 4, a blue and then a 5, a blue and then a 6. So that's 6, 12, 18 possibilities. So how many more are there? Well, if I don't get a blue or a red, I can get a yellow and then a 2. I mean, a yellow and then a 1, a yellow then a 2, yellow 3, yellow 4, yellow and then a 5, and then roll a 5, or I could spin a yellow and then roll a 6. So how many different possibilities do we have? We have, 6 in the first row. So 6, 12, 18, 24. We have 24 different possibilities. Well, remember what happens is, notice in my sample space for the first event was 4. And then my sample space for the second event was 6. So my sample space for both events is 24. 6, 12, 18, 24. So instead of doing all this, we could just simply know that this sample space will be out of 24. So for number 9, it'll be out of 24. Or actually, it'll be out of 24. But I'm going to show you how to solve for these. Because the compound probability is multiplication, okay? So I can multiply the probabilities for each event and get my compound probability. For example, it says the probability of spinning a blue, and then rolling a 2. Well, what's the probability? Let's just look at the first event. What's the probability of rolling a blue? It is 1 out of 4. 1 out of 4. And then what's the probability of rolling a 2? Well, that's 1 out of a sample space of 1, 2, 3, 4, 5, 6. So the probability of both of these events happening one after another is less likely than each of these. So it'll be 1 times 1 is 1. 4 times 6 is 24. So you have a 1 out of 24 chance of rolling a blue and then a 2. Now let's look up here in our sample space, because the blue 2 is right here. That's 1. There's no other blue 2s. And there's 24 in the sample space, so this proves to be true. So let's go to number 10. Number 10 says it says the probability of rolling a blue and then a not 2. So what's the probability of rolling a blue? Well, we already said that's 1/4, because there's 1 blue out of 4 different sections. And then it says not 2. Well, what's the probability of rolling a not 2? That means I would roll a 1, a 2. I could roll a 1, I could roll a 3, a 4, a 5, or a 6. So that's 5 favorable outcomes out of 6 in the total sample space. So there's a lot more possibilities going there. So 1 times 5 is 5. 4 times 6 is 24. So that is the answer for number 10. Let's go into number 11. Number 11 says the probability of yellow and then even. Well, the probability of yellow, if you look here, there's 1 yellow out of 4. So there's 1 out of 4 chance. And then the probability of even is, well, even numbers are 2, 4, and 6. So that's going to be 3 out of 6, which is going to be 1 times 3 is 3. 4 times 6 is 24. And we can reduce this by dividing by 3. So if I divide by 3, let me move over a little bit. So if I divide each of these by 3, I can get 1, 8. Okay. Now let's look at number 12. Number 12. Let's look. It says the probability of spinning a red and then rolling an even number. Well, we already know even is 3 out of 6 because we just did that. But the probability of spinning a red, well, there's, how many reds are there? There are 2 reds. So that's 2 possibilities, right? 2 favorable outcomes out of 4 total. So it's going to be 2 out of 4. So this is going to be 2 times 3 is 6. 6 out of 24. And I can actually divide both of these by 6. So that's going to be 1/4. And that's my answer for each one of these. But sometimes a compound event will not be two different things. There'll be two separate events, but not always two separate things, like this is a spinner and then a die. Sometimes it's all in one, okay? So in this case, what we're going to be doing and finding the probabilities of is what happens when we're going to have these marbles in our bag. We're going to pick one out, find the probability of picking one out. So that's one pick is one event, and then find the probability if we pick one out and then pick another out. So we're going to pick one out, replace it, and then pick another out. Okay? So we're going to pick one out, replace it, and then pick another out. So let's see what this is. So let's go over number 17. All right, number 17, it says the probability of picking a black, and then remember, we're going to replace it, and then we are going to pick a white. What's the probability that we'll pick a black, replace it, and then pick a white next? Well, the probability of picking a black, well, how many total probabilities are there? There's total possibilities. There's sample space. 1, 2, 3, 4, 5, 6. There are 6 in our sample space. Okay? So the probability of black is 1 out of 6. And then the probability of white is, so we're going to replace the black if we pick it. And then the probability of white is 2 out of 6. So this will be 2, and this will be 24. Okay? No, not 24. This will be 36, because 6 times 6 is 36. And then I could reduce this by dividing by 2, and then I would get 118. Okay? Now, let's go over number 18. 18 said, what's the probability of picking the black first and then replacing it and then picking a striped? Well, picking a black is 1 out of 6. We just discussed that. But what's the probability of picking a striped? Yeah, that's 3 out of 6. And so the probability that both these events will occur is 3 out of 36. And I can divide both of these by 3 to simplify it, which is the same fraction, just a little bit smaller, and I get 1/12. Okay? So then we have number 19. All right, so we have number 19. And number 19 says the probability of white and then a striped. So we're going to find the probability of white, which is 2 out of 6. And then we're going to multiply that times the probability of the second event, which is probability of striped. Now we're going to replace this white that we pick. And so the probability of stripe now is 3 out of 6. And so that'll be 6 out of 36, which we can reduce each of these, which will be 1 out of 6 chance. So there's a higher probability that we'll get white and then a striped than maybe, let's say, like number 17, a black and then a white, because this is 1 out of 18, and then this was 1 out of 6. All right, let's go over number 20. So remember, we are replacing our first pick, And so what's the probability that we'll get not white? Well, not white is 1, 2, 3, 4. Striped and black, right? So there's 4 out of 6. And then the probability of stripe, so I'm going to replace whatever one I get first. So I got the same in the sample space. And that'll be striped, so it's 3 out of 6. So that'll be 4, 8, 12 out of 36, which we could divide both of these by 12, and we get 1/3 chance, a 33.33% chance. Now, so this is with replacement. So we replaced whatever pick we took first with replacement. And that's what we just did. Okay. And the last thing we're going to do, but I don't want to put a lot of emphasis on it, but I'm just going to go ahead and introduce it to you, is something called without replacement. And I want us to think about how this would change before we even go into it. So let's look at number 14. So I'm going to draw little lines here so we don't get mixed up. So let's go into number 14. Number 14 says the probability of blue and then a green. And without replacement means that once I pick the blue in the first pick, I'm not going to replace it when I pick this next green. And I want you to think how that changes the probabilities of the second event. So let's go into this. And so let's think about that. So what is the probability of blue on the first pick? Well, the probability of blue, there are 3 blues, because they say B, 1, 2, 3, out of 1, 2, 3, 4, 5, 6, 7, 8, 9, out of 9 in the sample space. Okay, 3 blues out of 9 in the sample space. And we're going to multiply that times the probability of the second pick. But what happens is it says without replacement. So when I pick a blue on this first pick, I'm not going to replace it. And so now, how does that change my probability of picking the green on the second pick? Think about that. Okay. So let's look into it. So it says, now we're talking about the probability of green. Well, the green is 2 greens. And how many is in my sample space now? Now that I've taken out that blue on the first pick. 1, 2, 3, 4, 5, 6, 7, 8. Because I didn't replace my first pick, my sample space decreased by 1. I'm still doing the same thing, multiplying my probabilities, but the probability of the second event, the sample space just went down. So I have a higher likelihood at picking this green than I did before. And so 3 times 2 is 6. 9 times 8 is 72. And so I have, let's say, I believe I can do this. I could divide these by 6. Let's see, 72. Yeah, so that's going to be 1, leave over 1. And that's going to be 2. So that's going to be 1/12. All right. And so let's look at number 15. 15 says the probability of green. So let me go ahead and regain my sample space because this is a whole new set here. It's number 15. I'm moving into a whole new set. It's not a continuance of 14. It's a whole nother question. So I'm starting with the same sample space. So I know my sample space is 9. So what's the probability of getting a green? Well, that's 2 out of 9 on the first pick. But once I get that green, I'm going to take it out. It's not going to be there anymore. And so now they want to know what's the probability of getting green, not replace it, and then getting a red. Well, getting a red is now, there's 4 favorable outcomes of getting a red, and there's only 8 in the sample space now. Look, 1, 2, 3, 4, 5, 6, 7, 8. Because I took out that green that I did on the first pick. And so now this is going to be 8 out of 72. Okay. Which is, I could divide both of these by 2. I know that at least. And so this will be 4 out of, let's say, this is going to be 3. Leave over 1. 36. And then I could still reduce this by another 2. So I could have reduced it by 4. It's going to be 2 out of, what's that? 18. And so I could have done it again. Let me make sure I got this right. Yeah. And then I can also still do it again. So this could be 1 out of 9. I could have reduced both of them by 8. But, okay. So 1 out of 9. So I got my simplified version. So, number 16. Number 16 says, let me make some space here and delete this. Number 16 says the probability, it's a whole nother question. So let me regain my sample space. Okay. Number 16 says the probability of choosing a green first and then another green. So choosing a green, probability of choosing a green first, P stands for probability, of choosing a green in the first pick, not replace it, and then choose another green. So the probability of choosing a green first in the first pick is 2 out of 9. But then I take out this green because I'm not replacing it. And now what's the probability of choosing a green? Well, there's 1 green out of 8 in the bag. So now I'm going to multiply it across. 2 out of 72. I could divide both of these. And then that would be 1 out of 36. And then number 17 says, what's the probability of choosing a green and then a not green? Choosing a green first in the first pick, not replace that green, and then not green. Well, what's the probability? Well, let me go ahead and get my sample space here in this bag. Well, what's the probability of choosing a green first? Well, that's 2 out of 9. And then I take out that green, and then I want to know the probability of not green. Well, that's a huge probability that I'd get a not green, because I can get a blue, 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 red, 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 red. So there's 1, 2, 3, 4, 5, 6, 7. There's 7 that are not green out of 8 in the second pick because I didn't replace the first. So it's going to be 14 out of 72. And you could reduce this. We could reduce this by 2. Okay, that would be 7/36. Okay, and I believe that's all you could do there. So, what we went over today is we reviewed sample space for compound events, and that when we do compound events, we multiply the probabilities of the first event and the second event to get our compound probability. Okay. And we went over with replacement. Whenever there's just one situation, we can replace the things that we took out. And then we went over without replacement. What happens to the probability of the second event when we don't replace the first event. Okay? And so I hope you have a clear understanding of compound probability. And let me know if you have any questions. Next week, we're going to be going over making predictions based off of compound probability. So if you need help with this today, make sure that you let me know, and I'd be happy to help.